Have you ever stopped to think about what's happening behind the screen when you, say, book a flight or check the weather or order some food? All of your apps, they're constantly talking to each other, sharing data in this complex, totally invisible dance. Well, today, we're going to decode that secret language. So really, how do they do it? How does your weather app get real-time data from some national forecast service? Or how does your ride-sharing app pull map data from Google? It's not magic, not at all. It's all thanks to something called an API. And we're about to break down exactly what that means and how it powers pretty much everything you do online. The simplest way to think about an API, that's Application Programming Interface, is to just picture a waiter in a restaurant, okay? You're the customer, the app, the kitchen, well, that's the server where all the good stuff, all the data is kept. Now, you don't just walk into the kitchen yourself, right? No way. You give your order to the waiter, the API, who then goes to the kitchen, gets exactly what you asked for, and brings it right back to you. It is the essential middleman of our entire digital world. So here's our game plan. We're going to start with the classic ways apps have always talked to each other. Then we'll get into the modern stuff built for pure speed. After that, we'll dive into the real-time revolution, which is super cool. And we'll wrap it all up with a simple guide to help you figure out which API is the right one for the job. Okay, let's start at the very beginning, the foundation of it all, the classic request-response model. This is the absolute bread and butter of how the web was built, and honestly, how most of it still works today. At its heart, it's as simple as it sounds. You're just placing an order for data. The most common type you're going to run into is called REST. So if an API is a waiter, you can think of a REST API as that friendly, super flexible waiter who just gets it. They understand simple instructions, and they get the job done without a ton of fuss. There's a really good reason it's the default choice for most web and mobile apps out there. And here's why REST is just so popular. It is so simple. It uses the same basic commands your web browser uses. Things like get to fetch data or post to add something new. It usually speaks in a language called JSON, which is just a really lightweight and easy to read format. And here's a crucial part. It's stateless. That means our waiter completely forgets your last order the second it's delivered. And that makes it incredibly scalable, letting it work with just about everything, from your phone to your web browser to, even your smart fridge. But what if you're not just ordering a burger? What if you're, transferring $1 million between banks? For that, you need something way more formal, way more buttoned up, and that's SOAP. If REST is like a casual conversation, SOAP is like a notarized business contract with super strict rules and security baked right in. And when you put them side by side, you can really see the difference. REST is all about flexibility. It uses that lightweight JSON format, which makes it absolutely perfect for fast-moving web and mobile apps. SOAP, on the other hand, is rigid. It uses a much stricter format called XML, and it's the go-to for big enterprise systems. Think banking, healthcare, anywhere that security and rock-solid reliability are just completely non-negotiable. Now, REST and SOAP are powerful for sure, but they have their limits. And that's exactly why the next generation of APIs came along. They were designed specifically to solve the classic problems, focusing on modern performance and really on precision. One of the biggest problems with a traditional REST API is what's called overfetching or underfetching. Basically, you either get way too much data back or not enough. And that is a huge problem, especially for apps on your phone running on slower networks. So for example, just imagine your app needs to do one simple thing, display a user's name. That's it. But when it asks the REST API, it gets back their name, plus their email, their address, their user preferences, and their entire shopping history. That's overfetching, and it just wastes bandwidth and slows everything down for no good reason. And this is exactly where GraphQL comes in. It was actually created by Facebook to solve this very problem, and it's a total game changer. It's like instead of just ordering an item off the menu, you give your waiter an incredibly specific shopping list. Your app sends one single request asking for only the specific data fields it needs, and that is exactly what it gets back. No more, no less. One request, perfect data, every time. Okay, now let's switch gears and talk about pure speed. What if you need the absolute fastest communication possible? Maybe between all the different little services inside your company. For that, you're going to want gRPC. This is Google's modern take on APIs, and honestly, the best way to describe it is the Formula One race car of the API world. And I really do mean fast. In a lot of situations, gRPC can be up to 10 times faster than a standard REST API. It pulls this off by using a super compact binary format and all these modern network protocols to just squeeze every single last drop of performance out of the connection. And visually, the difference is just staggering. Look at that. I mean, REST is fine for most things, don't get me wrong. But when you're a company like Netflix or Uber, dealing with millions of tiny requests between all your internal services, the massive drop in request time you get with gRPC isn't just nice, it's a complete game changer. So far, we've only talked about your app having to ask for data. But what if we could flip that script? What if the data could just come to you the very instant it's ready? Well, welcome to the real-time revolution, a totally different way of thinking about how data flows. The old-fashioned way to get updates is called polling. It's pretty inefficient. Your app has to just constantly bother the server over and over again, asking, anything new? How about now? Anything new yet? It's like walking out to your mailbox every 30 seconds all day long just to see if the mail has arrived. It's a huge waste of time and energy. Webhooks completely flip this model on its head. So instead of you checking the mailbox, the server rings your doorbell the exact moment a letter arrives. When something happens, like a new order comes in on Shopify or someone pushes new code on GitHub, that service instantly sends the data right to your app. No more asking, just instant notifications. It's so much better. But what if you need a constant, two-way conversation, not just a doorbell ring, but an open line? That's what WebSockets are for. Think of it like opening a permanent, private phone line between your app and the server. Once that connection is established, both sides can talk and listen at any time without having to dial again. This is the magic behind live chat apps or getting real-time stock price updates. And for the absolute peak of real-time communication, you've got WebRTC. This is the technology that powers services like Google Meet or Zoom. What it does is create a direct peer-to-peer connection between two browsers, your video and your audio stream directly from your device to theirs, completely skipping the server in the middle. It's faster, it's more private, and it is the backbone of all modern video conferencing. Okay, that was a lot. I know. We've gone through waiters, contracts, race cars, doorbells. So how do you actually make sense of all this? Let's bring it all home with a final, super practical guide. And here it is, your API cheat sheet. At the end of the day, this all comes down to just using the right tool for the right job. Building a general-purpose website? Your friendly REST waiter is probably your best bet. Handling secure bank transactions? You absolutely need SOAP's formal contract. Need to make all your internal services talk to each other at light speed? Time to get in the gRPC race car. And for anything happening in real time, you've got your choice of doorbells, open phone lines, and direct video calls. Each one is a specialized tool with a very specific strength. You know, these APIs, they're the invisible building blocks of our entire digital world. They're the language that connects every single service that we use every day. And understanding how they work isn't just for developers anymore. It's for anyone who really wants to get how the modern world is actually put together. So, now that you speak the language of the web, what will you see differently next time you open an app?